Okay, so let's share my screen here. This month we are talking about Scintilla, and Scintilla is an edit control for source code that provides a lot of features like syntax highlighting and code folding, and uh, if you integrate it with a debugger, it can provide the little symbol that indicates which line you're executing in the debugger, and it can provide the kind of things you see in various IDEs where they put like a little red squiggle underneath improperly formed syntax and so on. All of the visual features of an IDE can be provided by the Scintilla control. It's not a debugger, it's not a compiler, it's not a uh, implementation of any particular language, but it gives you the ability to display all that related information for source code in an edit control so that you don't have to re-implement that whole look and feel of what an IDE looks like. And if we go over to their homepage, let's make that a little bigger. So this is the scintilla.org. This is their homepage for the current version of the code. As we will see in our example, we're going to be using a slightly older version, but pretty much everything is similar, if not identical. And we'll just scroll down here, and in their documentation, they have this little table of contents, and these are all the kind of features that are provided by the control. So there's, you can set and get text into and out of the control. There's support for selection. There's support for multiple selections. So-called virtual space selections, so you can drag out a rectangle as opposed to just dragging out individual lines. It's got cut, copy, paste. It's got search and replace. Overtype mode, so you're changing from inserting to overtype when you're editing the text in the control. It's got an undo and redo stack. It's got a change history, so you can highlight what portions of the what portions of the text in the control have changed most recently with some kind of visual indicator, scrolling, white space, cursor, so on. The part that we're going to be looking at in our sample code is down here with this section called the Lexer and the Lexer object. We'll be implementing a Lexer object that implements this interface. This is the Lexer 4 interface. We'll be implementing a slightly older version, but it's going to be very similar. So the way this documentation is organized is there's a core control that implements all the behavior, and then that core control is attached to a piece of code that performs the interaction with the GUI. So there's the what you might call the business logic of this control, which is managing all those features. And then there's the visual state of the control where it interacts with the GUI platform that the control is instantiated on. So there's one version of this control that you can use in wxWidgets. There's a version of this control you can use in GTK. There's a version of this control you can use in Qt, and so on. So in order to avoid having to repeat the same information over and over again, but recast in the terminology of a particular GUI framework, the way the documentation is organized is it's grouped into features by these little links in the table of contents, and that takes you to a section where there's a list of what kind of looks like function call descriptions, but they're this control, I believe, originated on Windows, so it's discussed in the terminology of messages that are sent to a control or notifications that are sent to the application from the control. So an example of an event, an example of a message is something like the application makes a request to the control to get some text from the control. Or Yeah, so here, if we look at this documentation for this get text message, so you give it a position. Uh, the position is a type defined in their framework. We'll see what that is. It's basically like just an unsigned int. Um, this length is the number of characters at most that you want to retrieve, and then this text argument is the destination buffer that will get filled in with the text, and then the return value indicates, I think, how many characters were actually copied into your buffer, or it may indicate an error if you gave a position that was invalid or something like that. So that's an example of sending a message to the control, and then a notification from the control is a thing like they clicked in the little margin area that is used to indicate folding or unfolding chunks of code. So you need to get that notification that they clicked there and take the appropriate action to hide or unhide some folded text. So as you can see by like position of the thumb on my scroll bar here, there's quite a bit of documentation here for all these messages that are describing all the different features. I'm pressing page down here, and we're like 20 pages down. We keep going. Here's a good example of kind of a screenshot showing you some of the features in here. These columns to the left of the text are called margins, and you can have, I think, an arbitrary number, but like by default there can be, I think there are 5 margins initially allocated. And here they're showing a margin with, a number in it, not necessarily a line number, but it could be a line number. They're showing a margin with, I think this margin is displaying text where the first number is like a revision number, and then there's a colon, and the text afterwards is the author of the revision. So this is showing like version history, like a git blame. And then you can see here there's a margin with a little minus sign next to this function, and that's a fold margin. So if you clicked on the minus sign, it would collapse that definition for that function. Here's a class class declaration. You could collapse the class declaration. Very similar if you've used Visual Studio or any other kind of modern IDE. They have this idea of like collapsing sections of code to kind of get a broader view of the code rather than just looking at every single line. So this control has a lot of features, and what we're interested in is this Lexer facility. The Lexer facility is used to support syntax, highlighting, coloring, the idea that keywords would be colored in one color, and maybe literals, like string literals, be colored in another color, comments get a third color, and so on. And the control itself comes with a large number of Lexers that they've already been implemented that support that coloring and folding behavior. So if you have to edit a bash script, they already have a Lexer for bash. And what you would do is you send a message that sets the Lexer. Get Lexer set. This is the legacy one. Oh no, okay, sorry. Here's an example where it's a little bit different. This is Scintilla 5, and I've got the documentation for Scintilla 273. Is it 273 that I'm using? I am using 372, sorry. 3.7.2. So this is from 2016. Okay, so this documentation, it's organized the same, but some of the specific messages are different. In particular, the Lexer support has been refactored significantly in the new current head of Scintilla, so that the Lexer is factored out into a separate library. It's not tightly coupled to the Scintilla control itself. But in 3.7.2, it is tightly coupled, and they have the set Lexer message that you give it an integer, and that picks one of the predefined Lexers that's already implemented in Scintilla. Now that's cool if what you're editing is, say, like a bash script for which somebody's already written a Lexer. But if you have your own custom language, like I do, that means you have to implement your own Lexer and you have to do something else. And to do that, you basically have to implement a shared library plugin and call, or you have to invoke the load Lexer library message. You have to send that message to the control to get it to load your shared object that implements a Lexer interface. And that's what we're going to look at in detail in just a few minutes. Now, I'm not using a raw Scintilla control. I'm using, let's see what the size is on here. I'm using the wxStyledTextCtrl widget from wxWidgets, and there's a corresponding wxStyledTextEvent. And I mentioned that there were notifications that the control may send to the application. When those notifications take the form of some kind of custom notification that's specific to the Scintilla control, they arrive in the wxWidgets framework. They arrive to your application as wxStyledTextEvents, and you bind to those events to get those particular notifications. We will see an example of that as we look at the sample code. You might ask, what is it that I am implementing? And that is, if we go over here and then go to the online docs. So this is an open source Fractal renderer that I've been working on, and it has a fractal type called formula, where you write your own code that describes a formula in the complex plane that is iterated, and depending on the bailout criteria determines when the iteration is over, and then the number of iterations that took place is used to color that pixel that was iterated. The pixel represents a position in the complex plane that is iterated. Now, the formula type, it has this, control structure business, if, else if, any number of else ifs and an else. Otherwise, the flow of control is sequential, and each statement is basically organized on a single line. But there's also comment lines that can be present. There's a bunch of built-in variables. There's a bunch of built-in functions. And what I've implemented is coloring for the keywords, these control keywords. And I implemented coloring for the built-in functions. And I implemented folding of these control statement expressions or control statements. So that's my example that I've implemented, and I've done that. I did not make a custom control. I just instantiated this wxStyled control, and in the documentation on wxWidgets, they basically have grouped basically every message from the Scintilla documentation that you would see. So let's move these two together. So basically all these messages turn into methods that you call on the control. So for instance, if we look at margins, instead of let's go back up to here and go look at apples to apples here, margins. So instead of this set margins message, excuse me, there's a set margins. There's a set margins method on this control. So instead of sending a message or anything that over here that's oops, this is the documentation we want. Let's close this one since we don't get confused anymore. all these messages that are described here, they basically turn into method calls on the styled text control in wxWidgets. Now, similarly, there's the notifications, and those come in form of a wxStyledTextEvent, and these macros are the old way of binding to events with a kind of MFC event table. We'll be using the new preferred style of subscribing to events by calling bind. But for these different messages or different notifications, for instance, the drag over notification, the wxWidgets documentation tells you which getters on the event structure are relevant that contain populated information for that notification. So when you're in this documentation here and it's saying, a certain notification is sent, like here, if you click in the margin, it sends a margin click notification, and then there's going to be modifiers, position, and the margin that was clicked on, and then over in the so this is margin click. We'll search for margin click. For some reason, they didn't put an underscore between those. So down here, they're saying the valid event functions to get the corresponding data from the wxWidget event structure is get margin, get modifiers, get position. Those were the ones that were mentioned over here. But there's also whether or not the get modifiers tells you which modifier keys were held down at the time of the click. But there's also, it's broken out that you can find out if the Alt key was held down or the Control key was held down or the Shift key was held down. So these are just basically shorthand for calling the get modifiers and masking out the particular modifier of interest. So that's how wxWidgets packages everything up. And although the wxWidgets documentation is good in terms of it's basically saying, here's the methods you can call, here's the events that you might receive. Really, you want to be using the Scintilla documentation because it's going to give a lot more detail about how all these things interrelate. So rather than duplicating all of this information in the wxWidgets documentation, the wxWidgets documentation explicitly tells you you're going to want to refer to the Scintilla documentation. Now, let's go over here. In my example, actually we can look at it on GitHub since it's a little bit better display. What I did, because I'm going to need to refer to the documentation of this older version, 3.7.2, right? Scintilla.org has like 5.1 or whatever the current one is. There are places where it's significantly different. And because the wxWidgets documentation is telling me, go look at the Scintilla documentation, I can't go to scintilla.org and read that documentation there because they don't keep the old versions of the docs online. It's just the current version. So what I've done is there's a Scintilla mirror out there. Scintilla is hosted on SourceForge, the primary source, but there's a Git mirror on GitHub. So what I did was use a Git submodule to get the Scintilla Git mirror, and I've attached my submodule to the hash that's associated with the tag rel 372, which is their 3.7.2 release. And that was primarily just to make sure that I had access to the documentation. But in addition to the documentation, there is some include files that I'm going to need, specifically this ILexer.h. This has the pure virtual abstract interface that I need to implement. Sorry, not that one. That's the extended one. This base one, ILexer. That's what I need to implement in order to get syntax coloring working for my custom language. It turns out really you just need to implement this lex method. let's make that a little bigger. You really just need to implement this Lex method to get the coloring. And for the code folding, you implement this fold method. The other stuff is kind of plugin framework glue for Lexers. And in my case, I just basically stub them all out with basic, do nothing implementations. Except for version and release have to do something useful. The rest of them just be stubbed out and basically say I don't have any information to tell you if it's a getter or if it's a setter. It just doesn't do anything. So let's take a look at some code. Let's go over here. I'm going to close this little thing because I don't need that. Okay, so here's my top level CMake lists. I've gotten in the habit of things that I do repeatedly in CMake across projects. I've gotten in the habit of like factoring them into little functions or little CMake modules that I can include to get that done, so I don't have to keep looking up the magic recipe or whatever. I can just have these functions and do what they just do, something really, really simple. I'll just show you an example. Like here, CMake standard 17 or C++ standard C++ 17 involves just setting a couple of CMake variables. So if I just include that, I get the variables set correctly. I don't have to look up what variables I need to set to get the behavior that I want. And then in modern CMake style, the way you get everything coordinated is by basically setting properties on targets and relating targets to each other. And I found that there were various things that I was doing over and over again in terms of properties that I was setting. And sure, I can't, like, for instance, I like to organize my targets into folders in the IDE. And so I was doing, set target properties, target name properties, and it was always just one properties lets you set multiple properties all at once, but I was always setting just the single property of folder to whatever, whatever folder I wanted the target to be displayed in the IDE. So to me, it was just simpler to create my own little function target folder that I give it a target and a folder, and it sets that property on the target. It turns out with, if you're using the folder property of targets, you also have to set a global property that turns the feature on. It's off by default. So, just factoring those things into little functions made my life easier, especially if I'm going to do this over again. This target prefix, we'll see how that appears when we get to looking at the CMake for the plugin. VS Startup Project just ends up being at your top level CMake, you can specify the name of a target that when you load the solution in Visual Studio, it will be set as the default target for the debugger. So, it'll be set as what Visual Studio calls the startup project, right? Visual Studio in the Solution Explorer shows the startup project in bold. So if you don't specify that, it just ends up being whatever the first project is in your solution, and it ends up being like all_build, and that's not a target that you can run in the debugger, and it's almost never what you want as the startup project. So again, just some CMake conveniences that I'm doing to make my life easier. Another thing that I just hit on today, actually, is I was noticing, okay, in my IDE, I had, if you make here's my gtest unit test executable, and CMake will always add the corresponding CMake list.txt where that target was defined. It will always add that to the project for the target that it creates for the target, at least with with the Visual Studio project generator. That's what we're using here. So if you're using make files, all of this is irrelevant. You don't have an IDE. There's no visual display of targets. There's just the make file, right? Thousands and thousands of lines of generated script that you can scrape through in grep or sed or whatever in your editor to try to understand what's going on. But I have all these other files, my client format configuration, my editor configuration, my git ignore, my git modules file, my GitHub workflow YAML file. I've got CMake presets. I've got a README. I've got a JSON file that I'm using for a VcPkg to get my dependencies. If we look back over here on GitHub, go back to my project. One more. You see I've got VcPkg as a submodule, and I've got my VcPkg JSON file that's describing my dependencies, gtest and wxWidgets. It turns out, I'll just mention it, there's also a Scintilla port in VcPkg, and that just gives you raw Scintilla. It doesn't give you Scintilla wrapped up as a wxWidgets control. And if you use that Scintilla port, if we go over here to vcpkg.io, browse packages, and put in Scintilla, that's giving you the latest one, the version 5. Now, if you get that, you get the Scintilla edit control as a raw Win32 control. It's not wrapped up as a wxWidgets control. So if you need the features from Scintilla 5, that's another way to get it. Now, I didn't need the version 5 features, so for me, this 372 was perfectly fine. And I've also got something new here that I haven't shown before with respect to VcPkg is I've got this VcPkg overlays directory, and that's because while I was working on the sample code for this, they GitHub updated all their workflow runners. So when you run the build, compile, test cycle on the GitHub machinery, they updated the images for all those runners for Mac OS and for Ubuntu and for Windows. They updated the CMake to CMake 4.0. And a bunch of the packages in VcPkg hadn't been updated to work with CMake 4.0 yet. So I had in here what's called an overlay port in VcPkg. And it's the simplest way for you to substitute your own version of a dependency to replace the dependency provided by VcPkg itself. So to do that, you have to specify a default registry. If you specify it as built-in, it's going to end up using the registry that's checked out with this VcPkg submodule. The baseline here is just the git hash of the submodule that I'm using as my registry, because the recipes for dependencies in VcPkg, they evolve over time. That's the main reason I use VcPkg as a submodule, is to use a fixed point for the recipes so that the underlying dependencies aren't changing underneath me when I didn't expect it. I'm using the version of the recipes that's associated with the submodule that I have attached to my Git repository. And that submodule is checked out at this hash. So that's the baseline. And by specifying an overlay ports, which is just a list of directories relative to this JSON file. So this is the simplest way to configure my source tree to contain some alternate recipes for VcPkg dependencies. And in my case, I needed to tweak libuUID, which is only used on Ubuntu. That was having a problem with CMake 4. And wxWidgets itself was having a problem with CMake 4. And the bottom line is it boils down to, if, for instance, in the case of libuUID, they're supplying the CMake list itself with the dependency recipe from VcPkg. And CMake 4 deprecated support for any minimum version below 3.5. So if what this code originally was in VcPkg is it just said CMake minimum required version 3. And what would happen is you would use CMake 4 to try and bootstrap your dependencies through VcPkg, and it would fail to build the dependency because the version was 3, and they dropped all support for versions less than 3.5 in CMake 4. There's another way to avoid this problem, and I ended up kind of doing them both, which is in your GitHub workflow, you can also configure CMake to a specific version. So first I fixed it with an overlay port, and then I was like, oh, I can also lock down a specific version of CMake that's used in the environment when the workflows are running. So I did that as well. So I kind of fixed it twice. Technically, I could get rid of this overlays thing, but that's just kind of an aside of a way that you can customize VcPkg either to override an existing recipe that's not working for you, or it's got a bug and you know how to fix the bug, but they haven't fixed it upstream yet. So, for instance, this libuUID recipe got fixed at some point after I deployed my own fix. But not only can you use that to override the recipes for dependencies supplied by VcPkg, you can also use it to expand the set of recipes supplied or understood by VcPkg to supply your own dependencies in here. You can provide your own recipes. For instance, if you were going to use Scintilla 5, Scintilla 5 broke out the Lexers into a separate project called Lexilla. And if we go to VcPkg.io, so in Scintilla 5, the way you write a custom Lexer is to use the framework provided by Lexilla, which is a completely separate component. But if we go to the list of stuff supported by VcPkg, we see that they provide Scintilla 5. There's no feature here to bring in Lexilla. And if we, Lexilla, if we search for Lexilla, there's no recipe for Lexilla. So if you were trying to do this in Scintilla 5, you'd still need to go and do this kind of submodule approach to pick up Lexilla, if that makes sense. At any rate, so that was just a brief aside about how to do some recipe substitution for dependencies with VcPkg. And I recently, or just today, realized I could add a custom target and add all these other random files so that they appeared in my IDE. So this miscellaneous target over here, it doesn't do anything. I mean, I could try building it, but I don't think anything happens. It's like it's doing a CMake configure, but it didn't actually do anything because there's no buildable code associated with that target. It just has a bunch of stuff. So here's like my Clang format, my editor config. Here's my little CMake scripts that have those little helper functions in it. Here's my Git related stuff, my Git ignore, my Git modules. Here's my GitHub workflow YAML file. Here's my little JSON files related to VcPkg. And of course my top level CMake lists, which previously wasn't associated with any particular target, so it wasn't directly navigable from the Solution Explorer. My presets and my README. So just maybe that makes your life a little nicer if you're browsing code. So having talked about that, there's my unit test executable that I'm going to use to write unit tests against my Lexer. There is my little tool that this is basically the simplest wxWidgets program that can host my Lexer. So this has a frame derived from wxFrame. That frame has a, where are we at? It is here, the wxStyledTextCtrl. This business up here, this is just setting up a menu bar with some menu items on it. So here's my text control, and then these little helper methods are initializing the Lexer onto the styled text control, initializing the configuration of coloring, initializing the line number state and the folding state. And then I've got some event handlers down here. Let's go back up here to the class declaration. It's easier to see them together. These are my event handlers that are responding to events. These three and this one, those are responding to events from the menu bar, so they're receiving wx command events. And then this on margin click is receiving that styled text event from the styled text control. So this is my little test application that I'm using just to host the control and see if things are working. We can run this and we'll show you what it looks like. So, file, it's got to quit. And then under the view menu, I can view line numbers and folding. Folding is on by default. Line numbers were off by default. If I turn off folding, you'll notice one of those little margins disappears. So if I write in here, if x greater than 1, z equals z times 2, else if x is less than 1, z equals z divided by 2, else z equals z times 3. In this language, semicolon begins a comment, so anything after a semicolon to the end of the line is a comment, and I need an end if here. Now you notice my keywords turned blue as I completed them. That's my syntax coloring. And unrecognized identifiers are just purple. I did mention that I had implemented the functions, so let's just see here, like cos of z. So the built-in functions I've implemented, the styling as red, and the comments, the styling is green. And if I view the folding margin, you can see that I've got the little fold indicators here on these different chunks of nested code. So that's what I used to interactively test my Lexer. And this is working as a plugin. So if I mentioned earlier that if you're not using the built-in Lexer in this version of Scintilla, this 3.7.2 version, if you want to supply a custom Lexer, you have to call load Lexer library, and then you give it the name of a plugin to load. I found that in order for this to work reliably, there's two things that I had to do. One is, three things really. I had to make sure that I was using the appropriate file name extension for the platform. So this static method getDLL extension for a library type. There's also a module type. On most platforms, a library and a module end up being the same. Like on Windows, they're both DLLs. But on Mac, a library is a dilib and a module is a framework. So they have different extensions on Mac OS. So that's the first thing I had to do is make sure I got the file name extension correctly for this called the load Lexer library, because the whole reason I'm using wxWidgets is to get a portable GUI across Mac OS and Windows and Linux. So I don't want to just hard code .dll into there. If we go back over here to my repository, you'll see that when I run a continuous integration build, I'm compiling and running my unit tests on Ubuntu, on Windows, and Mac OS. So I'm keeping them all working. I'm developing on Windows, but I'm making sure that through continuous integration on GitHub that everything is working on Mac and on Linux. So this was the first little wrinkle that I had to do. Second was I had to make sure that the plugin is copied to the same directory where in my case, this tool example, Scintilla example, I had to make sure that it was copied to the same directory where this executable lives, so that when I reference it by a relative path, it will get loaded. And I had to do the same thing in my unit tests. And that's why I wrote this little function, target copy Lexer plugin. I'm going to implement that by adding a post build event as a custom command on my target. And the command is going to do CMake -e, so CMake-e is a way for you to get a portable way to do like various file system operations like copy of different, echo, so on. That is, they works in a cross-platform manner. So I'm using that ability of CMake to execute a command. The command is copy. The source file is the target file from linking from my formula Lexer target. This is my plugin. And I'm going to copy that to the directory corresponding, the target directory corresponding to this other target. This syntax here, this is what's called a generator expression. You can look it up in CMake. It's a way to get at these various aspects of it. In my case, I'm getting at the target, the directory associated with a target file, and the full path to a target file. The source is my plugin, and the destination is whatever target I've passed into this function as an argument. So if we go up here and look at the CMake list for my example, you see I'm saying target copy Lexer plugin Scintilla example. And for my test, I had to do the same thing, target copy Lexer plugin test-Lexer. And that's because my tests are going to operate the same way as my wxWidgets program. They're going to load this plugin as a shared library, and then we're going to pretend we're acting like, we're going to pretend we are the Scintilla control and use the same mechanism that Scintilla control uses to load this Lexer plugin, so we can get some function pointers, namely, if we go back over here to this documentation, and we go down to the Lexer, and then there's this Lexer object. We're going to get a pointer to this interface so that we can call these methods lex and fold. That we're going to test them all, but these first methods, they're going to be basically boilerplate, not have any meat in them. It's the lex method that's going to have a bunch of meat in it, and the fold method. So we're in our test, we're going to load our plugin the same way that Scintilla would, so that we're making sure that that dynamic load mechanism that Scintilla is going to use to plug in our Lexer, we're going to make sure that that operates correctly by using the same mechanism to load the Lexer for testing. So we need to make sure that that Lexer plugin object is available at the expected location for our test, as well as our little GUI example. So here's that basically covers the plumbing for the tool and the test. It's very similar. For my Lexer itself, I've got a little header file that I want to share between the consumer of my plugin and the implementation of the plugin. So I've created a little interface library for that. It just contains that one header file, and the header file just contains an enum that indicates the different kinds of syntactical elements that my Lexer can generate. And I also wrote a little helper function to convert that strong enum into an integer. You notice this little business here, that's GitHub Copilot making little AI suggestions as I navigate around. So if you see that flashing up and wonder why you don't ever see that in Visual Studio, that's why. I've been using Copilot, and it's been pretty helpful. It's not going to put me out of a job anytime soon, but it's kind of like an eager programming assistant, and most of the time it's an accelerant. Okay, so this little formula syntax, it's just an interface library that contains just this header, so I can share that between the tests and the application and the implementation of the Lexer itself. For the Lexer itself, in CMake, when you call add library, if you don't specify shared or static, the person who's building your code gets to choose through a CMake variable whether add library with no mention will be either shared or static. Now, in my case, I'm building a plugin, so it has to be shared. And my Lexer shared object plugin, it's going to depend on a thing called LexLib, which I'm going to get from Scintilla. I will show you what that is in a second. It's also going to depend on my little formula syntax interface library. And I'm going to organize that in the IDE into my plugins folder. That's why it's over here under plugins. And I need to set the target prefix for my plugin to empty. The target prefix is a platform-specific value that on Unix type platforms, it will be set to the value of lib, and on Windows, it will be empty. Now, I can't have my file name for my plugin changing depending on the platform, because that was the whole point of trying to do it in a platform-independent way, was so that everything was named the same. So if I'm going to explicitly set this target prefix to empty so that my plugin will be called formula-lexer.dll on Windows. It'll be called formula-lexer.so on Linux, and it will be called formula-lexer.dylib on macOS. And as we saw previously, I used that static function in my code to get the right text for the dynamic library extension for that particular platform. But I can't have it have the lib prefix on some platforms and an empty prefix on others, because then I'd have to compensate for that somehow in my code. So the easiest thing to do is just tell CMake not to use any sort of prefix for the target at all when you link it and produce the final executable file. So if I just set that to empty, then it's always formula-lexer.something instead of formula-lexer.dll on Windows and libformula-lexer.so on Linux and so on. So just a little wrinkle that I bumped into as I was working in this plugin framework. So if we go look at my source file from my Lexer, now the first business is we have to implement the external library interface that Scintilla is going to use to load my Lexer from this plugin. So this is the plugin API portion. The plugin API portion consists of, you write a function that returns an int that says how many Lexers are implemented in this plugin. You write another function that takes an int and an output buffer pointer and a buffer size, and copies into that buffer the name of the requested Lexer at that index, right? So if in my case, I'm implementing a single Lexer. The Lexer at index 0 has the name id-formula, and there's another function you write that returns a factory function for an index, and the factory function will be used to create an instance of the Lexer. So this is a function that returns a function pointer, and the function pointer that's returned is used to create an instance of your Lexer. So in my case, I only have one Lexer. I return this function called create_Lexer. All of my implementation is inside an anonymous namespace. These functions that are part of the plugin API, they have to be declared extern C, because it's going to use on Windows, it's load library, get proc address. On Linux, it's dlopen, dlsim. It's going to use this name as a string, and that name, we have to declare it extern C so this name doesn't get mangled by C++ name mangling during linking, because if it was name mangled, then there would be extra text indicating the type of the return value and the type of the arguments and the number of arguments and so on. That's going to make it impossible for you to use dlopen, dlsim, or load library, get proc address to load these functions. So they have to be declared extern C. And on Windows, furthermore, they have to be declared decl spec DLL export so that they appear in the list of exported symbols from this DLL, but that's Windows only. So usually you're doing things Windows only, and or any kind of platform variation, you can paste over it or wallpaper over it rather with a macro, which is exactly what I'm doing. It turns out that on Linux and on Mac OS, when you compile code, all the symbols are quote unquote exported by default unless you do something to make them hidden. So the default is that we don't need to do anything on the non-Windows platforms to get these symbols to be exported so that they can be dynamically loaded. And then there's a further thing, this SCI method. If you see anything beginning with SCI, that's Scintilla. And if we drill into this macro definition, it comes from the header file that defines these interfaces, the interface for the document and the interface for the Lexer. We haven't looked at the document interface yet. We will in a bit. And it turns out on Windows that SCI method thing expands to _ standard call. And the standard call is a historic thing from 16-bit Windows, like Windows 3.1. And it turns out there was two different ways that the compiler could pack up the function call arguments onto the stack frame. Standard call was one way, and then there was, I can't remember which is which. There's one way that was basically for Pascal and another way that was for C. And I can't remember I can't remember a standard call is the C style or the Pascal style or what have you. But the important thing is we have to agree with the calling convention for function call arguments on these methods. We have to agree with what Scintilla is expecting. And Scintilla is expecting them to be standard call on Windows. So our functions need to be decorated with this same symbol, not only for these plugin API functions, but also for the functions that we write that implement the methods on these interfaces. So that's the plugin machinery that's used to get an instance of our Lexer. Our factory function is called create Lexer. It just news up a Lexer on the stack and returns the raw pointer. You might ask, how does that raw pointer get freed? Well, if we look at the ILexer interface, there is a method called release, and that is the way that the pointer is freed. So if we look at my implementation of release, we go to my Lexer, it just does delete this. Okay, so the create Lexer does new, my factory function, way down here at the bottom. It does a new. And my release method does the delete. Now here's where I mentioned there's a bunch of boilerplate stuff. There's this version method. If we look at the base method, there's this version method. It's supposed to return the version of the ILexer interface that is implemented. I implemented LV original, which corresponds to this base interface. If you want to support a fancier version that has these substyles, you can return this other constant from here, and that would tell Scintilla that it's safe to cast from this base interface to the derived interface. A bit hokey, but it works. It's one of those things that's like, it works because that's how everybody does it, as opposed to like worked by like guaranteed by the standard. But just so you know, that's what that version is doing. If we go over here to my implementation, I'm returning DV original, so I'm indicating that I only support that base interface, and the release does the delete of the this pointer. And here's the boilerplate business for the features that I am not really doing anything with. It turns out that in the Lexers that they've implemented for languages like C++, which pieces of text are considered keywords, isn't decided by the Lexer itself. It's decided by the container of the Scintilla editing control. And the way that they do that is so that the container sends a message to the Scintilla editing control, which ends up coming down to the Lexer, where they call word list set with an index into the list of word lists that are supported by this Lexer, and a string that sets the word list for that index. And so if we look at the Lexers for like C++, you're looking through the implementation of the C++ Lexer, and you're not seeing the keywords like while, for, do, etc. Instead, those are being set by the application that is containing the editing control, which to me was a little bit weird, but it provides a certain sort of future-proofing flexibility. If you go to the Scintilla site, they have a complete code highlighting editor that they've implemented called SciteE, SciteE. And if you look at the Scite source code, which is also mirrored on GitHub. So if we go over, look at Scintilla here, let's just kind of get that in a new tab so we can get that back in our repo. And so inside this mirror repo, they also, I think it's just Scite. Yes, so here is the Git mirror for the Scite editor. And this is the, the 5.0 one, so it's using the Lexilla component and the 5.0 Scintilla component. There's tags here for the, got 185 tags. So you can go back and get the 3.7.2 version of the Scite editor. But if we look inside their source code for Scite, we will see that in their source directory, their SRC directory, there's a bunch of these property files. And if we look at the one for CPP, bunch of properties that set, the kind of file name extensions that are associated with this Lexer. But if we go down in here, we also see this keyword class.cpp. So there's all your C++ keywords that you're used to seeing. So the keywords that are defining, or rather, this editor application is configuring the Lexer with a list of words that will be recognized as keywords for C++. And you might say, well, that's kind of goofy. Why isn't the Lexer doing it? And I didn't see any design rationale for why they did it this way, but my feeling is they did it that way so that as the language gets updated, C++ 17, C++ 20, 23, 26, and so on, and they add new keywords, they don't need to distribute a new binary to get appropriate highlighting support for those new keywords. You just need to go and edit this properties file and add the new keywords into this little dynamic definition of what constitutes a keyword. And as soon as you edit it into that file, and then you tell your editor that it's a C++ file, it's going to highlight that new keyword without having to get a new distribution of your binary. Now, for my purposes, my little formula language here, first I only have a few keywords. This is all of them right here. I have some built-in variables, which I haven't implemented highlighting support in terms of a different highlighting color. I did implement the functions, the built-in functions. So first of all, I only have a few keywords. And secondly, this is going to be, this formula Lexer is going to be bound up and distributed with my application. So I didn't feel that I needed that extra level of indirection supported by these word list sets, or rather setting word lists on the Lexer. So for me, it's just a stubbed out implementation. Now, to get to, you know, kind of the meat of the matter here is in my Lexer, there's the lex function and there's the fold function. And it turns out there's a couple of helper classes that are provided in Scintilla that are going to make your life easier when you implement a Lexer. And now we're getting into the part of this talk that isn't so well documented in their documentation, because we're deep into the guts of how to implement a Lexer. And in their documentation, they basically say, go look at the examples that are in, you know, the existing implementations that are in the source code. And to make your life easier, what I did is I have 3 libraries that are basically pulling information from the Scintilla submodule that I've attached to my Git repository. So first is this interface library called Scintilla. So I've got that over here. And this basically just has those header files we were looking at. We looked at the ILexer. So we looked at ILexer.h. We were looking at the stuff in there, but there's also you see inside this ILexer.h, it uses this ScitE. I'm going to say ScitE instead of Sci. There's the there's the Scientific Computing Institute at the University of Utah. So when I see SCI, I always think ScitE. Anyway, this ScitE position is implemented in a little header. It's either they have a signed type and an unsigned type and a long type. All the methods we'll be interacting with use the int version. Oh, I guess that's not true down here. These are unsigned. At any rate, that little header is included at the top here. So we need access to that. So this is why you'll see why in a second as we start drilling into this that it's easier to just have the entire Scintilla repository checked out at the appropriate revision as a submodule rather than just copying a few of these files over. Because if it were just these few little header files, sure, we could copy those into our tree, and that would be fine. Here, this scintilla.h, this file is generated. You see here it says auto-generated from scintilla.iface. This is their abstract definition of their interface for all their messages and all their notifications and all the associated constants that are used as arguments to those messages or returned by notifications. So this file has a bunch of pound defines that are, you know, defining these magic values that represent different pieces of the API. And you can see there's quite a number of them. And then there's some structs at the bottom, you know, representing these notifications and stuff. Now, turns out from wxWidgets, we don't need to consume this scintilla.h file directly. There's a version of that generated file that's included with wxWidgets, and we'll see that when we look in a little bit more at the GUI application. But from the point of view of the Lexer, you need this ILexer.h. That includes this ScitE position.h. The other header files here, you know, they're kind of, you know, maybe useful to look at, but you don't need them directly. However, that's just this first library that I've generated. This next library, LexLib, this is a library of helper classes that are used by all the Lexer implementations. Well, not every class is used by every Lexer implementation, but these are helper classes that you can use when writing your own Lexer. And if you want, when writing your Lexer, if you want to follow the style of the existing Lexers, you need those helper classes. So I've made a static library that I called LexLib. I just included everything from their LexLib folder. So off here in the Scintilla submodule, there's a LexLib folder. Those are all the files that I included in that LexLib library. And their example Lexers are in this Lexers folder. You can see here's for Ada, for assembly language, for ASN.1 notation. Here's the CPP one. And it can be useful to have those existing Lexers to refer to while you're writing your own Lexer. You know, it's like, well, how does the C++ Lexer do this? Go look and see what they do. How do they decide? How did they implement highlighting? How did they implement folding? So it can be useful to refer to those. They're included in, I have a little CMake option here to include them. It's on by default, but you could exclude them if you didn't need it, because none of this code in this Lexer examples library, none of this code is used by my code, but it's handy to have it available in the IDE, so they can go over here and say, like, okay, how did they, do this highlighting for bash shell scripts or whatever? It's just handy to be able to have that available. And one reason, for instance, if we go look at, if we look at the Scintilla header file for ILexer, and I use my IDE to say who derives from ILexer, I gotta press the right keystroke. We see that here's mine. That's in the formula Lexer target. Targets become projects in Visual Studio Generator for CMake. But here's all the other ones. You can see that this is coming from ReSharper, by the way, showing me derived implementations of this interface. I got to press the right key. It's Alt down. The ones that are shown in bold directly derive from ILexer, so that's what mine is. And we can see that, like, the assembly language Lexer directly derives from ILexer. But we also see some down here that are not bold, and that's because they ultimately derive from ILexer, but they derive from something else in between. So if we go and look at that, we see that Lexer CPP derives from that fancier Lexer interface, ILexer with substyles. And if you see who implements the fancier one, well, it's C++, Python, and Verilog. And if we go to the base class of ILexer with substyles, it takes us to the ILexer interface that everybody else derives from. So by including this Lexer examples code in my CMake lists, it lets me browse existing Lexer implementations, even though I'm not using them. It lets me browse them and kind of use them as example code that I can work from. So I found that to be very handy. But just so you know, none of my code depends on this Lexer examples, but I do use this Lexer lib. And rather than, by the way, the Lexer lib, it doesn't really, there's an implementation in source code, but there's no like doxygen comments on the methods or anything like that explaining to you how it really works. So I'm just going to give you a brief overview. I figured it out enough to kind of reverse engineer enough of its behavior to figure out what I should be doing. So I mentioned that there was this document interface. That's how the Lexer interacts with the text that is held in the control. So the document interface lets you do things like get or set the fold level for a particular line. You can find out the line state, whether it's hidden or not. There's also this these styling methods. The styling methods are what are used to colorize the various pieces of text. So there's an abstraction in between the visual representation and the semantic information of the text. What your Lexer does is assign a semantic category to ranges of characters, and that semantic category is referred to as the style. So when you run your Lexer, what it does is walk over a chunk of text. The Lexer is given a range of positions, but the starting position will always be at the beginning of a line. And the Lexer walks over that range of text, and from its tokenization or whatever kind of parsing mechanism you want to use, You can use regular expressions, or you can use, recursive descent parsing, however you choose to recognize the different syntactical elements of your custom language. When you recognize an element, you mark a range of characters as having a particular style. Then the edit control maps that style number to a set of visual attributes, and we will see when we go look at the configuring of the edit control in my application, my sample application, how that works. But from the point of view of the Lexer, you have a range of characters that you identify as belonging to a particular syntactic element, like a keyword, and you tell the document, I'm going to start styling characters at this position, and then it knows what the current position is. It kind of remembers it, and as you work through the document, you say, take the next length characters from the current position and set them to these particular styles. It's kind of a low-level interface. This set style for sets a length of characters to a single style. This set styles takes a range of characters and assigns individual style codes to individual characters by taking the style codes from an array that corresponds to one style code per character for the given length of text. So it's kind of a low-level interface. And the helper classes in LexLib, they give you this LexAccessor and this StyleContext. And pretty much every single Lexer that's implemented built-in as one of the built-in Lexers uses these two classes to traverse the document. And I'm looking at the fold method, but it's the same up here in the Lex method. So this accessor provides some helper utility code around this document interface, and then this StyleContext class is what you use to mark the document as you walk over it character by character. So this StyleContext, you notice it takes the start argument that was passed to my plugin, and it takes the length argument that was passed to my plugin. It uses that start and that length to obtain the entire range of characters all at once from the document and holds them in a buffer, and then gives you a little pointer that says, you start out at the beginning of the buffer, and as long as this more function returns true, there's more characters for you to process, and you advance past a character by calling this sc.forward. So it acts kind of like an iterator with a Boolean function that tells you if there's more characters, and a little function called forward that you use to advance to the next character. Now, to implement my simplistic parsing here, I start out in an initial state, and then I may terminate the current state, and then I may do something to begin a new state. And when I terminate the current state, it may tell me to advance the character forward, or advance the little buffer pointer forward. So in my case, I've got a little state machine here, and this is where I'm using that syntax strong enum from my shared header file that's shared between my tests and my implementation and my application. So this is basically a little, switch on state, do something, and decide if I need to change state. The actual current styling state is held in this StyleContext. So I'm switching on the value in the StyleContext. And when I said these things weren't very well documented, if we, there's this comment up here, but then, there's a bunch of methods. Some of them are inline, some of them aren't. None of them have any documentation. You pretty much have to, do a little bit of reverse engineering to figure out how it works. But it's not terribly complicated. It's not like it's 10,000 lines of code or something, but it's just kind of something you have to do to figure out how to use these classes. And so I'm recognizing comments, keywords, white space, built-in function names, and any set of stuff that I didn't recognize. I'm just calling it an identifier. But only if it's in this identifier character set. So they have a character set class that basically you can say, give me a representation of something that represents alphabetical characters or alphabetical characters with numbers, or no characters but only the ones in this supplied string. So in my case, I made a little white space character set that was just the space tab, vertical tab, and form feed, the characters I want to recognize as white space. So you can just use them to say, does that character set contain this particular character? You know, it's just a simple way to do character set queries instead of using the CC type header from C++ standard library. And you'll see that what I'm doing is I'm changing the state on the style context as I reach a transition point that indicates the next character can't be part of the current syntactical element that I'm parsing, so I have to switch states to something else. So when I'm finishing the current state, I'm finishing the current state because the current character is not part of a valid characters that make up the current state. So it's not, you know, a comment ends at a new line, so I set the state back to none, which is kind of my boilerplate, you know, doesn't represent any specific kind of element. Basically, all of these, they do some kind of check, and they set the state to none if the current state should be ended. And then to begin the next state, I have to, you know, say, if I'm in an identifier, I have to do some things to find out, you know, maybe when I'm in an identifier, it could turn out to be a function name, a predefined function name, but they haven't typed the whole name yet, or I haven't scanned the whole name yet, or it could be a keyword and I haven't scanned the whole keyword yet. So I have to kind of build up an idea of, like, am I at some place where it might be a keyword? So I have to go and get that keyword. The part that I've scanned so far doesn't contain the current character, so I have to append that on. And then I'm using their little word list class to say the current text. In my case, my language is not case sensitive, so the keywords could be uppercase, lowercase, mixed case. It wouldn't matter. I have to recognize them all as valid. So I'm using this get current lowered thing to get them as lowercase. And then this one character that I'm appending down, I have to use CC type to convert it to lowercase to make sure everything's in lowercase. Look it up in the word list. And if I have scanned this character and now represented a keyword so that the current text is in the list and the next character is not part of the character set associated with keywords, then I'm going to change the state. Before I was calling set state associates the style with the current character. If I call change state, it sets the style with all of the characters up to and including the current character that have the same style as the current style, if that makes sense. The current style is stored in this state member. So this is kind of going in the buffer that's maintained by that style context, and it's not marking just the current character as a keyword, it's marking all the characters from the last time I changed state to the current character as being part of a keyword. Similarly for function. So this interface, this, style context interface, it's a little funky. You have to do a little bit of reverse engineering to figure out how to use it. And that's why I wrote unit tests around this stuff, because it was just lots of little details that were easy to get wrong. And that's basically my Lexer. I'm going to march my little state machine across this range of characters, and as I identify syntactic elements, I'm going to set this, they call it set state, but it's the style associated with the characters. The style is just a number, 0 to, I think there could be up to 256 styles. I'm using a strong enum here with a const expr conversion operator to int because all their APIs wants int, right? But I wanted to use strong names to refer to things to make sure that I wasn't getting myself confused. Instead of saying to, I wanted to say, syntax, identifier, etc. For folding, it's similar, except instead of styling individual characters when you're folding, you set the fold level for the lines as you process the lines. So the standard way of doing it is you get to the end of the line, and then you've done some analysis of the line up to the current point to identify, is it something that should be foldable? In my case, I am just using this fold level header flag associated with the level. So the level is a number, an integer number starting at 0 and increasing for increasing indent levels. And this fold level header flag indicates that this is a point that could be collapsed. This line indicates a line where you could fold from here below, and anything at the level below this level that's set for the line with the fold level header flag set, anything with a level lower than that after this line would be folded. So it's easier if we just look at this, how it goes in this little sample here. So if x greater than 1, and then inside here you can say if x greater than 2, and then inside here if x greater than 3, do something. And if the indentation doesn't matter for my little language, I'm just doing it to keep it visible. So I can collapse that, I can collapse this one, and I can collapse this one. And if I expand them back out, the intermediate fold state is remembered. I didn't have to do that. That's all being managed by Scintilla. So all I'm managing is the click here to decide to tell Scintilla to collapse or not. Or I actually just tell it to toggle the collapsing. And it handles all the rest of that logic. And the reason it's able to do that is because I'm setting this fold level and this flag at appropriate places as I processed all the lines in my fold method. My fold method is a little simpler than my Lexing, so it's just kind of all in one method rather than calling any helper functions like I factored out here from my Lex method. So that's basically it. To do the simplest implementation, there's some functions you have to implement it as part of the interface. If you're not supporting these property sets or anything like that, you can just leave them all empty. I didn't mention this PrivateCall method, but there's a way that if you have custom functionality that provided by your Lexer, maybe you've done the Lexing and now you've got some additional information you'd like to convey back to the containing application. There's a way that you can evoke this PrivateCall by sending a message to the control, and then it will return back information through these output pointers that you're providing. I didn't need to do any of that, so I just implemented as a stub that returns a null pointer. Now, in the application, I mentioned that the styles are just numbers, and the visual representation associated with those numbers has to be configured by the application. So here, I am doing that. I factored it into a little method that I call for each of these different syntactically significant elements that I recognized in my Lexer. So here, again, I'm sharing that enum between my Lexer implementation and my application. And you call style set font to set a font, and you can call style set foreground to set a foreground color. There's a bunch of different visual attributes you can set: foreground color, background color. You can set different fonts for different styles. In my case, oops. In my case, I am, let's do it this way. Let's go from here to where this is being called. I am using a typewriter font at 12 point, and I'm using that for all of my syntactical elements. I've just picked different colors, named colors, to go with these elements. And in wxWidgets, you can use wx from string to get a wx color from a color name. So I look up the color by name to get a wx color. I call set foreground to set that color to be associated with that particular stylistic element. And then I just do that repeatedly for the different elements. And I also set the font. You won't get any coloring at all until you call this colorize method. The method takes a start and an end position. If you start at 0 and color to position -1, that will end up meaning that your Lexer will be invoked on the entire document as they edit, or whether they load it from a file or whatever. The entire document will always get lexed by your Lexer. I mentioned there are in the documentation that there are for the control there are these margins, and you can have different numbers of margins. This I have a margin. I've just created a strong enum here for the line number margin. I'm using index 0 for the line number margin. I'm using index 2 for the folding margin. The documentation states that you can use any of the margins for any purpose, but the default purpose assigned to margin index 2 is for folding. I was using index 1 for folding, and there was no change in my code. But later I was like, oh, they're saying margin 2 is the default index used for folding, so let's use margin number 2 for that. Initially, margins, I think the folding margin number 2, this is one difference, is that it initially has a width of 16 pixels. If you set the width of a margin to 0, then the margin is hidden. And so what I do is I figure out the style. I'm using their constant indicating, give me text width and the style of a line number, and I'm just saying format this underscore. The underscore is taking the place of plus or minus, and then what is this, 5 digits? And so I'm saying, give me whatever the width that is, and stashing it away. And my show hide line numbers is saying, if I'm currently showing line numbers, this is application state. If my application wants to show line numbers, then I will set the width of that margin to this line margin width. Otherwise, I will set it to 0. And my menu item, which is a checkable menu item on the view menu, I will check that item if with the state of this Boolean. So this Boolean is basically toggling back and forth. That's why my little helper method here is called show hide. So when I initialize things, I'm going to call the show hide to get the checkmark state on the menu set correctly, and to get the width of the margin set correctly based on my application state. Same for init folding. I'm going to set the margin type of the folding margin. I set it to this constant wxStc margin symbol. And again, I mentioned over here there was that Scintilla.h file that had all these enums generated. The wxWidgets version of that is the include file wx/stc/stc.h, and it has all the same values generated, but using a wxStc #define instead of sci. So in the documentation, when you're reading about the messages or the notifications and they're mentioning constants by name, translate from sci underscore to wxStc, and the STC is the styled text control. Just so you know, so you don't need this. That's why I said you don't need this Scintilla.h in your application because wxWidgets is already generated using the same scripting mechanism from that .iface file. It's already generated all these constants for you. Now, in terms of folding, the margin is set to the symbol type for the margin, and then the symbols that are displayed in a margin for the different flags associated with folding, they all default to an open circle. So what I do is, if you look at the documentation, they specify that the marker numbers, so the symbols, they call them markers, and the markers are identified by these constants that indicate the standard markers. And you see that from marker number folder end to folder open, those are the ranges of marker numbers that are used to indicate folding state. So I initially set them all to empty. So this is the marker number, and then this mark symbol is indicating what kind of marker is associated with that number. So there's a level of indirection there that when you are displaying the fold margin, it looks at the Scintilla widget looks at the flags and uses the flags to pick a marker number associated with that is used to represent the state defined by the flags. And then the marker number is used to look up a marker that is displayed. So for all the marker numbers associated with folding, I initially set them all to empty, and then I only care to have two different distinct symbols. So for the folder open marker number, I choose arrow down, and for the folder marker number, I choose the arrow. These names, the folder open and the arrow down and all that stuff, is described in the Scintilla documentation in the section on markers and margins. So you don't have to reverse engineer this stuff. You just have to read through the documentation and understand how that works. The margin mask is how you specify which bits of the margin, it's which bits of the marker number at that line for the margin are used to separate the flag bits versus the folding level. So this mask here is a bit mask indicating that the high bits are associated with the marker number and the low bits are associated with the folding level for a margin that represents folding state. This margin sensitive business is I'm saying I want the folding margin to be sensitive to mouse clicks. I'm going to bind that stylized or styled text control margin click event to this event handler function on my frame class. It's going to use the this pointer as to decide which instance of this class to use when invoking this method. And you this is the kind of the newer style of binding events in wxWidgets. It's dynamic instead of using the kind of MFC event table dispatching mechanism that we've talked about the last time we talked about using wxWidgets. But basically, this is the ID of the control. This is the instance of the class that will receive the event callback. This is the event callback function, and this is the event that will trigger the notification. And then I'm going to sync my my UI folding state to my application variables. Again, same thing. Now, I'm doing this set property because they recommend it that I'm not consuming the property in my Lexer. If I wanted to get fancier and have the Lexer do nothing when this fold property was set to 0, I'm not going to be operating on like documents that are hundreds of thousands of lines long. So I just do the folding all the time. But when folding was turned off, I would set I'm setting this property, this fold property, which is it's they don't have a document describing like standard properties, but pretty much all the Lexers observe this fold property. So I guess what I'm saying is I'm doing this to be nice, follow their recommendations, but my Lexer basically ignores it. So it doesn't have any operational effect. And again, if show folding is true, I'm giving this margin a non-zero width, in which case it will be displayed. Otherwise, I'm giving it a 0 width, in which case it will be hidden, and I'm updating the check state. And my event handlers are really quite simple. For these show hide menu items, I'm just toggling the Boolean and resetting the GUI to represent the state of the Boolean. And then down here, this is the only one that's kind of really interesting, is when you click in the margin, I'm telling the widget, toggle the folding state at the line corresponding to the position reported by the event. So this get position here, this is not XY position on the screen. This is, if we go back to the wxWidgets documentation, you see that this get position, it returns the zero-based text position associated with this event. So that's one of these SCEI position values corresponding to this event. So when I click in the margin, I get a document position, but a document position is not a line number. So I turn that document position into a line number by calling line from position on the StyledTextCtrl, and then I say toggle the folding state on that line. And that's because toggle fold takes a line number, not a position. And if you were doing some testing and getting weird results, it might be because there's no strict data type difference, right? This toggle fold, it takes an int, and this get position returns an int, so there's no strong types to prevent you from confusing a position with a line number. So you just got to be careful when you're doing that. Now, having done all that, let's take a look at the tests, because it gets kind of interesting. So I mentioned that the test is going to do the same plugin mechanism that the Scintilla editing control would do to load my Lexer. So I have to do what that control would do. And as I was doing this, I thought, well, let's just use wxWidgets portable dynamic library mechanism to do this, so I don't have to write platform-specific code for loading this plugin in my tests. I can just write one piece of code, and these tests will run the same on macOS, Linux, and Windows. So I wrote this little get exported symbol helper. It takes a dynamic library and calls get symbol on that library to get a function pointer. So I'm using that to say, hey, my plugin, it better provide a symbol, or it better provide a function pointer for the symbol name get Lexer count, get Lexer name, get Lexer factory. This is testing that the plugin exported the necessary functions for it to work correctly with the Scintilla code. And then I'm testing that, when I call these functions from the plugin API, they're returning the things that I expect. And here I'm using fixtures to factor out common setup. And if we look inside here, we see that it's calling the load method to dynamically load these plugin shared objects. This is a method on this member here is a wx dynamic library, and we call load with a path to a file name, and it loads that as a shared library. Now, I had to do another little bit of funny business. You notice here I have this wxlog set active target, because it's always a good idea to write the failing test first so you know what happens when it fails, so that when you implement it, you know that you implemented it correctly and the test passes. What I found is that when I'm using some of these wxWidgets helper classes like wxDynamicLibrary, they assume that it's running, kind of in a GUI application. And the default logger was causing a message box to pop up. Now that's fine if I'm writing an interactive application, but I can't have that in the context of a unit test, because it's going to pop up this dialog box in an automated test run. There's going to be nobody there to dismiss the dialog box, and then a test runner is just going to hang and eventually get killed after it times out. So I set up a string stream. I set up a wxLog stream associated with that string stream. And then before I do anything in my test fixture setup, I set the active logging target to my logger, which is associated with a string stream, so that instead of popping up a dialog, it's going to scribble a message into this output string stream. And in my case, I don't care what the message is. I'm just giving it a place to put it rather than displaying a dialog box. So that's just something to be aware of when you start using some of these wxWidgets classes in the context of a unit test. Always make sure that you write the test and have it fail first, so you see what the failure behavior is, because if I didn't make it fail first, I wouldn't have known that I needed to do this logger stuff to get things to be running correctly in an automated scenario. All right, so that's just a kind of a wxWidgets aside when doing unit testing using some of their helper classes. So let's get down to the more interesting part here, where I am going to... So here I am doing that teardown. Remember that I said that you have to call release to delete the Lexer that was created by the Lexer factory. So here in my setup, I'm getting the factory function. I am invoking the factory function to get an instance of the Lexer. I've got a little asserts here to make sure that the functions that I'm loading dynamically are actually there for me to call, so this doesn't just crash. And I'm asserting that the instance I got back from the factory was not null. And because that's a raw pointer here, this mLexer, it's a raw ILexer star. So in my teardown, I'm going to be a nice citizen and clean up that Lexer by releasing it, so I'm not leaking memory. And then once I've got that common setup and teardown in my fixture, my Google test fixture, I factored that out. Now I can just start testing those boilerplate methods to make sure that the boilerplate methods are doing what I expect. When I start to test the actual Lexing, I'm going to need to mock out their document interface. So I've created a mock object for their IDocument. And I'm just going to say, here's some text that I want to Lex. Here's all the stuff I expect my Lexer to do to the document as it does the Lexing. And the only really interesting, this part up here, all this stuff, I'll be honest, I didn't write these expectations first. I just called the code and see how that accessor class and that StyleContext is going to make a bunch of calls on the document. I'm not really so concerned about the specifics of those calls, other than like they should do something reasonable. So I basically ran the test with a strict mock, let the test fail, see what it was actually doing on the document, and then I wrote expectations for those calls on the document. The only really interesting part is that when they ask the document for a range of characters, I'm going to give it I'm going to copy my text into their buffer. I'm going to use stir in copy, because they're giving a char star output buffer pointer and a length. I'm going to use stir in copy to copy my text from the point where they asked to begin and however many characters they asked for. So when they call getCharRange, I'm going to be stir-in copying from my, this is a std string that I've got in my fixture. So I'm going to be copying from my std string into their char buffer. And then this is the only other interesting part, which is I'm saying when I lex this text, I expect the styles to be set in this way. So it turns out that the way their code works is after your Lexer has traversed all the characters, you've marked all the style bytes in an internal buffer in that style context, and then in your Lexer, at the end of Lexing, you call complete on the style context. I was initially missing that, and so all my tests were failing until I figured that out. When you call that complete, it calls set styles to set a style number for every byte of text that was lexed. And in my case, I wrote a couple little Google test matchers, has repeated style bytes, and has style bytes to say, this has repeated, like there should be, this style byte should be repeated that many times. That's the expectation. Oops. Went the wrong way. Here we go. So when I call on my mock document, when my Lexer finishes and it calls StyleContext complete, that complete will invoke the setStyles method on the document. It better style as many bytes as are in my input text. And in this case, it's just a single semicolon. There's no differing syntactical elements in this input text, so they should all be styled with the comment style. And that should be a buffer containing this value, and it should be repeated that many times. I mean, I could have written, it's only a single character in this case. I could have just written one here, but I'm trying to write this code generically so that if you go up here and you change this text, then the test still passes. It's parameterized on the number of characters in the input text. And then here's where I'm invoking my system under text on my Lexer. I'm calling the lex method. I'm saying start lexing at position 0 and lex this many characters. Now, std string size, it returns a size t, right? It says size type, std string size type. Nobody writes that. It always ends up being size underscore t. I mean, if we chase through all these things, how many levels of indirection do we really need here before we get down to something that ends up being size t, right? It's just kind of crazy chasing of type aliases there. It's going to be a size t, but a size t is not an int. And, I got tired of typing this static cast to, ski position of whatever this size t thing is. So I just wrote this little helper inline, as position, as pos. So that's, if you're going to see this sprinkled through this test code, and that's what I'm doing there. And so after I got my, let's just take a single character comment, and that should be lexed as the comment style. Here's a longer comment that should, also be lexed as a single comment. Here's, 2 lines of comments, and, it gets a little bit wrinkly because now we've got these new lines in here, and again, that should all be marked as comments except for, I think what I did was I said that the style bytes I think this test evolved. I think initially the new lines were getting marked as none and the other characters were getting marked as comments, and then I decided that was a little silly. Because the new line is strictly speaking part of the comment, it's not some other non-comment syntactical category. So this ends up being the same as, all the style bytes are comment. And then it starts getting more complicated as you start. Here I did Lexing recognizing keywords, but I just did it as a parameterized test with I only have 4 keywords, so that was easier to do as a parameterized test. And then similarly, a parameterized test for all my function names. Function names are a little bit different because some of them have digits in the name, so they're not all pure alphabetic characters. And then it's time to start writing some tests where I mix things together, a comment followed by a line with a keyword. So I build up my expected styles. There should be some bytes representing the initial bytes of a comment, and then there should be some bytes representing the keyword style, yada, yada, yada. Just more and more complicated cases. What I found is that I thought that my Lexer was complete until I would run my little example, and then I would, type like if X, and it turned out it thought this was a keyword followed by something else, by none or whatever. Well, that's not right. The keyword has to be terminated by a non-alphabetic. So you can see it changes from blue to purple as I type this if X. So this interactive program was helpful in identifying gaps in my test cases that were pointing out bugs in my code. And this one was, and similarly, I started writing tests for my fold method. Here, this just got a little bit noisy in terms of like this business of satisfying the expectations on the document. I'm using a strict mock because I wanted to catch calls on the document interface. I didn't want it to do things that I was just going to let slip by. So it got a little bit noisy down here, but I was able to validate that this is the more interesting part down here, is which fold levels and flags were set on which lines in the document. So that's what the test code ended up looking like. Wow, this ended up being me talking a lot longer than I thought. But we're looking through real code here on how to do things for real, and not just talking about how this library works, but seeing how it actually works in practice. There was some stuff I had to reverse engineer, but it wasn't too bad in the sense that the classes are small and not too difficult to figure out. Probably the best thing that I did was early on realizing I needed a specific version of Scintilla in order to write my Lexer against, and it needed to be a dynamically loaded plugin rather than one of the built-in Lexers, and using the existing Lexers as a reference was extremely helpful. So using Scintilla as a submodule, checked out at the right version, making sure that when I consult documentation, I'm consulting the documentation from that checked out version and not the current version, which is a bunch of versions ahead, and using their LexLib code of helper classes. I ended up using this word list class and this character set class, this StyleContext, and this accessor. Using those made my life a little bit simpler because it was easier to make my code look more like the existing Lexers. I didn't have to do everything from scratch. I could have just used their raw IDocument interface and just called methods on that, but I probably would have ended up creating the same kind of helpers that they had anyway. So I thought this was going to be shorter. It ended up being longer, but I hope it wasn't too tedious or distracting. So this code's all up on GitHub, and I think it's a pretty complete example of how to do this in wxWidgets. It's complete enough that you could probably use it as a starting point for your own language. You have to do that. There's like 35 or 40 different Lexers that they already provide. So if you can get by using one of their existing Lexers, it's JSON, Perl, all kinds of stuff in there, just use theirs. It's just going to make your life easier. But in my case, I had a custom bespoke language. At some point, I will want to implement debugging support for this language, so the ability of the Scintilla control to display more margins where you've got breakpoint symbols specified at certain lines, and you've got symbols indicating what line you're executing, that's going to be extremely helpful for me. But my situation is kind of unusual that I've got this completely bespoke language that I can't reuse anybody else's existing implementation of a Lexer. So um, it was a bit of an interesting experience doing this. It took me a while to implement all this stuff, but now I'm in a state where it's pretty well working. I can test it interactively in my sample application that's simple enough in an isolated context, and it's sharing code with my tests. I do want to mention one more thing briefly that's just kind of a Visual Studio oddity. Due to the way dependency checking happens between projects, if you change your implementation, so if I go over here and I say I compile this code, this file, and then I do a build, it relinks my plugin, but because the source code in my projects that consume the plugin did not change, so meaning my test or my sample application, because these projects didn't recompile, the custom build step that copies the plugin, the updated plugin, to the output folder for these targets did not run. So if you find yourself when you're in this situation using these plugins and you've got post build steps in CMake to copy the plugins over to the places that are consuming them, and you update your plugin implementation and you build, and then you go run your test code or you go run your application and you say like, hey, it didn't update the plugin. That's why, because the I don't know if this is Visual Studio specific, the way the post-build steps work in the Visual Studio generator. I didn't try the Makefile generator or the Ninja generator to see if it had different behavior, but it's definitely this behavior in Visual Studio. The way I worked around it is when I updated the implementation and I didn't make a change to the test, I would just go back to the test, highlight a source file in the test project, Control F7 to build that one source file, and then if I build the tests, it will then run the post-build step because it relinks the test. It'll then run the post-build step and copy the plugin fresh over into the binary directory for the test. So just heads up, if you're using this plugin copy post-build step mechanism, I think it's just an interaction with the way dependencies work in Visual Studio. It's not smart enough to recognize that it should redo the post-build step. So just a little wrinkle there for you. Otherwise, that's all I got.